Hey there, Mac here with another video on periodic functions this time. But before starting the topic, I would like all of you to please subscribe to my channel as it will really appreciate me in making more content for you. So first, we will look at the definition of a function. Well, a function is just like a machine in which if we input x, the machine here is f of, and the output will then be f of x. So if I input a 1 here, the output will be a 3 here. So what's my function? My function is basically taking the input x and adding 2 to it. So if I input a 2 here, it will output 4. And if I input a 3 in it, it will output a 5. The domain of a function is the set of all inputs that a function can take. So if a function is not capable of taking some inputs, then it is defined in the domain. The range of a function, on the other hand, is the set of all outputs that a function can give. In this example that we have seen here, the domain and the range are both elements of the real number. That is, all the real numbers can be input in it, and the output will be the entire real numbers as well. So if I take the output as y instead of f of x, then the range will also be the entire real number line. Now we will look at periodic functions. Periodic functions are those functions that repeat certain patterns after a fixed duration. Well, what do I mean by that? So we will understand it with an example. If I enter the value 1, the function gives me an output of, let's say, 4. But if I enter 2, the function gives me an output of 5. If I enter 3, the function gives me an output of 6. However, if I enter 4, the function again gives me 4. If I enter 5, the function gives me 5. If I enter 6, the function gives me 6. If I enter 7, the function now again gives me 4. So there's a pattern which is being repeated here by the function's output. This pattern is of a 4, 5, 6. So for an input of 8, the value will now be 5 again. For 9, it will be 6 again. So this pattern here is repeating. This is an identification of a periodic function. Well, how common are these periodic functions? All the trigonometric functions are periodic functions, as they do repeat themselves after every 360 degrees. But where have we seen the trigonometric functions? Well, the sine, the cos, and the tan are three basic trigonometric ratios can also be seen as functions. But how come are they functions? Well, take inputs of angles in it. So let's see how their outputs behave when we plug in angles from 0 to 360 degrees. So first we will look at sine. where x will be the angle from 0 to 360 degrees. So it's in degrees. The sine function goes from 0 to 1, then back to 0 at 180 degrees, then it goes to a minus 1, and then back to 0 at 360 degrees. This pattern then repeats itself. So at 720 degrees, we will have two waves. At 720 degrees, we will have two waves. 360 degrees, we have one wave. The pattern is repeating itself after every 360 degrees. This is true for all kinds of trigonometric functions. We will look at the three trigonometric functions: the sine, the cosine, and the tan. The cosine here, the cosine function looks something like this. It starts from a 1, then ends at a 1. This is at 360 degrees. This is at 180 degrees. This is a 0. So the pattern now repeats. We will now look at the tan function. The tan function has two values at which it is undefined. That is the 90 degrees and the 270 degrees. At 90 degrees, there is an asymptote shown by a dotted line, and at 270 degrees, there is also an asymptote shown by the dotted line here. Well, asymptotes are basically lines that show that a function approaches them but never reaches them. So this is 180 degrees. This is the pattern for the tangent function, and it repeats after 360 degrees, just like the other two trigonometric functions. But we have looked at trigonometric ratios in the last video, and we wonder how come these ratios have become functions. Well, if we plug in the value from 0, then we plug in the value 1, then 2, and then so on and so forth, all the way till 360 degrees, and then we plot these points together and then join them with a continuous line, we will have values, and those values will look similar to the pattern that we have drawn here for the sinusoidal or the sine function. While the cosine and the tan are also similar. So, but we have also seen different real life variables following the same pattern. However, in my last video of trigonometric ratios, I told you that sine, cosine, and tan always take an input of an angle inside it. So how come there are graphs that show here a time period or any other variable? Well, what do we do here is that we first change these degrees to the the numerical unit for angles, and that is we change it to radians. What we then do is we multiply, we take it to 2 pi. So this will be our new graph for the sinusoidal. So the sine completes a complete cycle at 360 degrees, and 360 degrees is equals to 2 pi. So our new variable is the, so our new unit is the radians, so this will be 2 pi. So we have changed the measurement unit so that it becomes a numerical value. So now we will change the graph. If we want one cycle to be completed in, let's say, variable till 1, what will we do? If we want to 1 here instead of 2 pi, we will just divide the entire x-axis with a 2 pi. This means that if we have to convert it into a naturally existing number line, then we have to multiply all our values with 2 pi. So this leads us to another subtopic in which we will discuss the general numbers and how are they going to affect our periodic functions. So let's say we will deal with sine. This is a variable a. Then we have 2 pi n. Well, one thing you must have noticed throughout the lecture that the sine and the cosine gives value between 1 and -1, while the tan goes from negative infinity to positive infinity. So this amplitude, this A here stands for amplitude, and this will scale down this sinusoidal and this sine and cosine functions, which means that the sine and the cosine is now scaled to a value of a and minus a. This is the amplitude of our periodic function. So this is the amplitude of our periodic function now. While the time period is basically how many waves occur in 2 pi. So this is determined by the number n. If we increase the number n, then the number of waves that occur in this time period will become, let's say, double. If n is 2 here, this will double. And then if n is 3 here, it will become 3 waves in 2 pi radians. So while the c is the vertical shift, what does vertical shift do? The vertical shift will transfer the entire function to a new value. Let's say if I plus 1 here, the entire function will shift to 1, and then it's going to 2. So this function here is the same function of amplitude 1 sine 2 pi. It has single wave, so the n is 1 here, but it also has a plus 1. It shifts the entire function 1 unit upwards. Similarly, it can also be a negative number. So that was all for today. We might look at some examples and some questions from this topic in upcoming future videos. So stay tuned and thank you so much for watching.